Okay, so I have 2 grams of selenium in the reaction flask here that I pulverized in a mortar and pestle. I'm using a 3-neck flask just because. Why not? It seemed like the most convenient thing. The reaction of bromine and selenium just together is supposed to be pretty vigorous, so I wanted a vessel that would contain it if it decided that it was going to get a little spicy. The selenium doesn't look like much. It's just a black crystalline powder that this piece of shit probably... Oh, there we go. You can see. It's shiny, pretty. Got it off eBay. Anywho, what we are going to do, since this is atomistry and I don't really, know, we're just going to wing it like we normally do. I figure we will go with a little bit of water. Not much, just a little. Some hydrobromic acid. Since if you can produce, oops, shit. That's better. If you can produce potassium selenibromide by dissolving selenium dioxide in hydrobromic acid and then adding a concentrated solution of potassium bromide to that, then it stands to, and you can create selenium tetrabromide by reacting bromine and selenium, then it stands to reason that if we react the bromine and the selenium in hydrobromic acid, we will similarly end up with a hydrobromic acid solution of selenium tetrabromide. I am pretty sure that's how this is going to go down. Now, atomistry says that doing it this way, the solution will gradually deposit dark red crystals of an acid hexabromoselenate, so that's kind of cool. But I'll be happy if I can just get the potassium salt to precipitate out, or maybe I'll do ammonium, I don't know. We'll see how it goes. Alright, so here's the hydrobromic acid. We don't expect it to do much with that. I have no idea how much to add. I'm just adding what seems like a good amount. Which is a nice way of saying I'm fucking making it up as I go. Alright. Yeah, sure, that looks good. Okay. Now we stir. Focused, you piece of shit. There we go. Now we add some bromine to this. Oh, hello. Okay. Don't have a whole lot of bromine left, so we do want to try to make it count. Now, since selenium tetrabromide is probably not a great thing to breathe, we are going to limit our exposure to any fumes coming off of it. I don't know. Tellurium tetrabromide is pretty nasty stuff. It also dissolves in hydrobromic acid. Okay, I think that's good. Don't get that shit on me. Bromine is not as forgiving as concentrated nitric acid. Meaning that it burns pretty much immediately. Okay, everybody, here we have it. We have a solution of selenium tetrabromide in hydrobromic acid. There's probably a little bit of excess bromine in there, although not much. Actually, it was pretty easy to get the bromine very close to right, simply because there were little particles of selenium that kept floating on the surface of the liquid, and I would add a little bit more bromine and stir, and then they finally all disappeared. I heated it a little bit at the bottom, not much. I didn't wrap this up or anything, just a little bit of heat at the bottom. Stirred it, and everything's gone into solution. It's very hard to tell because it looks very dark, but it's actually a very deep, dark red. You can see here the transmitted light that goes through the solution. It is a nice red color. Isn't that pretty? So what I am going to do now is create some concentrated solutions of ammonium bromide over here and potassium bromide over there, and then we're going to add this shit to that, and we are going to take a look at the compounds that we get, and that'll be pretty cool, I think. So I will come back when I am ready to do that. Okay, we are going to try the potassium salt first. Let's see what that looks like. Here is a better look at what the solution actually looks like here. You can see it in the pipette. It is a beautiful red color. So, you focused, a piece of shit. Okay, there we go. Oh, yes. Okay, alright. Why does it keep disappearing? Is it breaking down? We're getting a precipitate, like Atomistry said. Maybe it needs to have some hydrobromic. Oh, maybe you need to do it the other way around. Oh. I bet you that's it. And that's why they said it had to be very concentrated. Okay, okay. Minor setback. We still have the ammonium bromide. Let's add a little hydrobromic acid to it to make sure we don't make it cranky. And then let's see if that makes it happier. Well, the color was much more orange than tellurium tetrabromide. And I wonder just how concentrated this has to be. Let's see. Does that make a difference? It seems to, and then it breaks down. Okay, alright. Different approach. Here is the ammonium salt. Let's add a significant amount of hydrobromic acid to that. Oh shit, no, fuck, it's gonna crash out. Well. I wonder. That's okay. I did dissolve a lot of ammonium bromide in there. Okay. There should still be some dissolved in the liquid here. So, focus. There we go. Okay. Alright. Okay. Does this work better? Ah, yeah, there we go. All right. We just have to keep it happy. Nice. Very, very, very nice. Excellent, in fact. God damn it. Hell yes. Okay. All right. Get a little bit more. That there ammonium bromide. Okay, I want to see, will it similarly work in here? Okay, yes, excellent, 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 excellent. Fuck it, we're going all out. It's all going to become the ammonium salt. It is what it is. Okay, alright. If we're gonna do it, let's fucking do it. There we go. Not dump acid on me again. That was very, very not fun. red fuming nitric acid. Man, thank God. That stuff was so concentrated, it actually did not really burn. Alright, here we go. Oh wow, awesome. I will be able to recover some of this. Excellent, excellent. I kind of wanted to see this thing drop out these red crystals it talked about. Oh well. Now that I know how to do it, I can always do it again later. Alright. Well, that's pretty goddamn cool. Well, we got a lot of it. That's awesome. Cool. I have something to put in my collection. Yay! Something I can send to Backyard Science 2000. He likes getting samples of all these weird compounds for his collection because he is a man of exquisite taste. Alright everyone, so after filtering off our product and pressing it dry, or dry-ish, this is what I've got here. I am going to attempt to dry it, or at least partially dry it, and we will see what happens. For comparison, this is ammonium hexabromotellurate. I didn't make it in a previous video. I actually did the hexaiodo-tellurate in the video, but I made the hexabromotellurate basically identically to how I did the hexabromoselenate here, and you can see the difference in the two, the difference in the color. The ammonium hexabromoselenate is more of an orange, whereas the ammonium hexabromotellurate is more of a reddish color. So I thought that was pretty cool. I wonder, does sulfur make an analogous compound? If so, I wonder what it looks like. Probably not. It's probably too small. Anyway, oh well. So, that was an interesting and different chemical. I was sure that I had done this at some point, but apparently not. So, there you go, y'all. Still doing videos on weird chemicals you won't see anywhere else. So if you liked that video, give it a thumbs up. If you didn't like it, well, whatever. Subscribe, comment, share the video, donate a few dollars if you can. God knows that's especially helpful right now. And until the next one, y'all, I will see you later.